Hello, boys and girls. Welcome to lesson 7-10. Today we're going to look at solving more complicated equations, okay, and we're going to make your life easier by decomposing functions. So, we've already learned many useful tools for solving equations, right? So we can simplify, we can factor, we can use substitutions, okay? So what we're going to do here is look at some complicated equations and think about what would be the best way to solve it. Okay, I'm sorry I can't be there with you today, but hopefully this video will serve as me for today. All right, so looking at the first example, it says solve each equation. Be sure to check for extraneous solutions. You may use a graphing calculator to check your answers. We have 2x minus 2,000 times x to the negative second equals 0. So right off the bat, when we look at this equation, okay, and we ask ourselves, what makes this one look complicated or hard, right? And I'm sure that we would all agree it's probably the x to the negative second power. So what we can do is we can take this and we can rewrite it as 2x minus 2,000. And let's go ahead and make that a positive exponent by moving it down below into the denominator. Okay, so now we just have an equation here that has a fraction in it. So there's a couple different methods we could use. Since we have basically two terms, right? We have this term and we have this term. We could turn this into a proportion by adding the 2,000 over x squared to the other side. That would result in 2x equals 2,000 over x squared. And then you can use the process of cross multiplying to solve the proportion. So we'd have 2x to the third is going to equal 2,000. We'll go ahead and solve this now, right? Divide each side by 2. We've got x to the third is going to equal 1,000. And then, right, we're just going to do our inverse operation, cube root of each side, and we will get that x equals 10. Okay, so that's one method for solving it. A second method we could do is we could take it and, if you wanted to at the beginning, you can multiply everything by the x squared, right? Let's say here we had 2x minus 2,000 over x squared equals 0. So if you wanted to take it here and just multiply both sides by what would be the least common denominator, right? So we'll end up here with our 2x to the third, right? Our x squareds would cancel out in that second term. So now you have minus 2,000 is going to equal 0. And then when you move your 2,000 over, we're basically, back to the same point we were with that original method, right? So there's several ways you can solve most of these equations. Okay, if you want to check it, right, remember we can solve anything by graphing. Let's get out the graphing calculator. All right, it's already set equal to 0, so let's do 2x minus 2,000, and we're multiplying that times x to the negative second power. And so when we graph that, we can go ahead and look to see where does that cross the x-axis. Well, you can see it looks like there's only one place where it crosses, and that is at 10. So we know that we are correct. All right, let's move on. So the next one, we have 60x squared times the quantity of x plus 1 minus 30 times the quantity of x plus 1 squared equals 0. Now there are multiple ways to solve this one. Some people may want to take it and simplify the whole thing out. If you want to do that, that's fine. I would look at it and say, hey, we have two different terms here, and do we have any common factors, right? Let's look for the greatest common factor between these. So what we have here, 60x squared times the quantity of x plus 1, right? So that's one of our terms, and then we have the 30 times the quantity of x plus 1 squared. So you can see 30 would be a factor of each of them, and then it looks like they're going to have an x plus 1 in each of them as well. Okay, so if we factor that out, right, what would be left over? Looks like we'd have a 2x squared minus 30s would cancel, and it looks like we have just the quantity of x plus 1. close it, set that equal to 0. Now, let's just go ahead here and simplify what's inside our brackets, right? This would be like saying 2x squared minus x minus 1. And then we have 30 times the quantity of x plus 1 still out in front. And at this point, we may want to ask ourselves, hey, does this factor, right? It's a trinomial. And because I'm bringing it up, it probably does, right? So I would say here this would be a 2x and an x. This would be a 1 and a 1. And we want more negatives than positives. So this would have to be a negative. That would have to be a positive, right? And we'll bring down everything else. And now we're just going to end up using our zero product property, right? Now 30, right, is just a stretch factor, so it's not going to have any impact on our answers. Let's just go ahead and deal with the rest of them. X plus 1 equals 0, 2x plus 1 equals 0, and x minus 1 equals 0. So x equals negative 1, x equals negative 1/2, and x equals positive 1. And then let's just go ahead here and check it by graphing it. So get out that handy dandy graphing calculator, clear out what's in there, and let's just enter in our original function. So we had 60x squared times the quantity of x plus 1 minus 30 times the quantity of x plus 1. And then remember that is being squared. And since it already equals 0, we don't have to enter anything else in. We'll go ahead and graph it. And this one's a little bit thinner, so we'll go ahead and zoom in. And you'll see it looks like it crosses at negative 1, at negative 1/2, and at positive 1, which is exactly what we said there. So there are the answers. Let's move on. So next one we have 1/2 x times the quantity of x squared plus 4 raised to the negative 1/2 power minus 1/5 equals 0. So when we ask ourselves that question, what makes this one look complicated? There might be a couple things, right? If we look at it here, right, we have this negative 1/2 power, and then we also have the fractions in it. So we can take the time here to get rid of some of this stuff, right? We can get rid of the fractions part of it, right? Let's just multiply each side by our least common denominator. So both 2 and 5 go into 10. So let's multiply both sides by 10. So now we're looking at 5x times the quantity of x squared plus 4 raised to the negative 1/2 power. And then 10 times negative 1/5 is going to be a negative 2. And then we get that equals 0. Okay, so still need to deal with that negative 1/2 power there, right? We know that's the same thing as the square root. So let's go ahead and move it to the denominator to get rid of the negative and then turn it into the square root. So this should be 5x over the square root of x squared plus 4. Right? And right now that's still minus 2 is equal to 0. And if it was me, right, so I've got two terms, so let's just make it into a proportion. We'll add 2 to each side. We've got 5x over the square root of x squared plus 4 now equals positive 2. Or you can think about it as 2 over 1. Let's cross multiply. We have 2 times the square root of x squared plus 4 is equal to 5x. Okay, and then we need to get rid of that square root, right? Remember, x squared plus 4 is not a perfect square. So don't, come at me like, hey, it's just going to be x plus 2. It's definitely not. Okay, so let's not do that. Let's go ahead and get rid of the square root by squaring both sides of the equation. So when we do that, remember, we are squaring both parts of this. Okay, and then we have to square both parts on the other side. So each factor gets squared. So we'd have 2 squared, which is 4. And then the square root of x squared plus 4 squared will cancel out our radical and give us 4 times x squared plus 4. There's no need to square the x squared and the 4 because they had the square root originally. On the other side, remember, we're going to square 5. We have 25. And then we'll have an x squared. And now we could take it here, and it's much more basic now. I'll distribute our 4 through. We've got 4x squared plus 16 is equal to 25x squared. And if we subtract 4x squared from each side, we should have 16 is equal to 21x squared. All right, I'm just going to rewrite it up here. 16 equals 21x squared. Right, get rid of the 21. And we now have x squared is equal to 16 over 21. Right, so we still got to do what we normally would, get rid of the square. So we'll take the square root of each side. And if you want, you could say here, right, this is like the absolute value of x. And we're saying that equals the square root of 16 over the square root of 21, which is really 4 over radical 21, right? And right now we're saying that's the absolute value of x, which will turn into plus or minus. And when we rationalize our denominator, we should have positive or negative 4 radical 21 over 21. Now, we need to check our answers. So let's go ahead and get out the graphing calculator. Go in, let's just graph that original function. So I've got 1/2 x times x squared plus 4. And then we're going to raise that to the negative 1/2 power. And then minus 1/5. Right, so when we graph that, ooh, it looks like a straight line. Let's see if we can zoom in a little bit here and see what's going on. Okay, and you see here, right, it looks like it only has one x-intercept. So that's what, 0.8728, right? So as we look at that there, okay, since we only have one answer, it looks like it's only going to be the positive answer, right? So we're not going to need the negative. The negative is not going to work here. And then we will check to make sure that our value is correct. So we're going to say 4 radical 21 divided by 21 should equal x. And let's see what that value is. So remember that 0.8728. And now we'll just type in 4 times the square root of 21, arrow out, divided by 21. And you see we get that 0.8728. So we know that we are correct. Yay! Okay, let's move on. Okay, so got another one here. Hopefully this is the last one, so I can go to bed. All right, we've got 3 plus the square root of 2x minus 1, and that's being squared, equals 4 times that same quantity, and then plus 12. Okay, so when we recognize on this one, right, we've got that same set of parentheses here with something kind of complicated inside. This is a great opportunity for us to use the u substitution. Okay, so we could take this here and let's just let u equal 3 plus the square root of 2x minus 1. Okay, so if we let that all equal u, that means on this side we have really just u squared equals 4 times u, and then we have plus 12. Okay, so that becomes much easier looking, right? So let's get everything equal to 0. So we'll subtract our 4u from each side, subtract our 12, set it equal to 0. Our favorite thing in the world, factoring. So we have u, we have u, we know we have different signs, and we need more negatives and positives, so we have minus 6 and positive 2. And then we still need to solve it though, right? So u plus 2 equals 0, u minus 6 equals 0, and so we get u equals negative 2 and u equals positive 6. What we're going to do next then is we are going to substitute our expression back in for u, and then we can solve it. So we've got 3 plus the square root of 2x minus 1 is going to equal negative 2. And then we also have 3 plus the square root of 2x minus 1 is going to equal 6. And now let's look at solving. So we're going to subtract 3 So I think you can probably see already where we may have an extraneous solution, right? We can't take the square root of something and get -5, but let's just say we forgot to do that so we can check it here anyway, right? We'll square both sides. We've got 2x minus 1 is equal to 25. We add 1. 2x equals 26, so x is going to equal 13. And then on the other side, we'll subtract our 3. We've got the square root of 2x minus 1 is going to equal 3, which means then when we square both sides, 2x minus 1 is going to end up equaling 9. We'll add 1 and divide by 2, so we've got 2x is equal to 10, so x is equal to 5. Okay, and then let's just double check it. So when I double check this one, I'm going to move everything over to the same side when I type it in on the calculator, right? I think it's easier just to look at the x-axis. So we'll go in here and we'll say quantity of 3 plus the square root of 2x minus 1. All right, close it, square it, and then we would subtract 4 times the square root of 3 plus the square root of 2x minus 1. And then we'll close that, and then we will subtract 12, right, because we've moved it all over. And now we'll look at our graph, and it looks like in this case, right, I'm looking here is our answer for 5. And then if you look over on the other side here, right, there's nothing here at 13, so that means that 13 was an extraneous solution. So we will throw that one out. And our answer is 5. All right, that's it. So please get your homework done. Behave for the substitute. We'll see if I'm back tomorrow. Yeah, I don't know. So otherwise, keep on doing what you're doing. I appreciate your hard work, and I will talk to you soon.